Hello class, I'm going to work some of your problems from your section 6.7 that you're working on, which is graphing the systems of equations. And then there's two additional things. Before we left class, we talked about how we could graph and find where the two equations cross and solve the system that way. Then the next part of 6.7 has two additional methods that are done algebraically. Now if you choose to, you can just graph and see where they cross. You can keep using that method, but I'm going to try to show you in this video some sample problems using the other methods. So before we do, I'm going to do, this will be off of your 6.7 work, and I'm going to review one where we use the graphing method. So we could graph each one of these lines, and again there are two lines, line 1, line 2, and we're looking for the solution, what will work for both of these equations. You might just sit and think about it for a while and think, what number equals 4 times a number minus 1, and also that same number y would equal a number minus 1. You might think about it. I think that's a hard way to do it, but I have students who, you know, that could work for you. That is the essence of what we're trying to do here. We're trying to find an x, y, two numbers that works in this equation that will also work in this equation. And so we have three methods to do that. One is graphing. So let me review graphing with you. So on the same graph, you will graph each one of these lines and look for where they cross. Okay, so we have different ways to graph, different methods we've talked about. One is the T-table method, where you just think up x, y points, maybe plugging in 0 and 1. A lot of times that's all it takes. Or you can use the slope-intercept method. So whichever graphing method you preferred. I'm going to demonstrate with a T-table. I'm going to plug in when x is 0, y will equal 4 times 0 minus 1. Right? If I plug in 0 for x, I would have 4 times 0 minus 1, and y would equal, that would be 0 minus 1 or minus 1. So that's a point I can plot. 0, negative 1. That would be 0 and then down 1, negative 1. Plotting another point, and it could be anything, but I'm going to plug in x is 1. X is 1 would give me y equals 4 times 1 minus 1. Or 4 times 1, 4, minus 1, 3. Y would equal 3 when x equals 1. So then I plot that point over 1, up 3. Once you dot in 2 points on the math program, it's going to draw that line and be finished. Then we'll start over again and we'll graph the second line. So now I'm going to do the second equation in this example, which is y equals x minus 1. I'm going to use the T-table method again for that and just pick two values for x, maybe 0 and 1. So when I plug in 0, y will equal 0 minus 1 or just negative 1. So I'll plot that point, and you know I've started over, so that line's done. I'm on to the second line. So 0, negative 1. Well, that's going to be the common point because I just dotted right over the last one I plotted there. But continuing on with my method, if I plug in 1 for x, y will equal 1 for x minus 1 is 0. So then I'll plot that point over 1 and 0 for the y. Then it draws those 2 points connected. And then your solution is that point where they cross. The intersection or the common point is the solution to a system. So stating that point, that would be 0 for x and negative 1 for y. And that again is the solution to the system. If we check it back in the original problem, we should see that this is the one value that works for both of these equations. When x is 0, 4 times 0 minus 1, it makes y equal negative 1. And then it also works here. When y is negative 1, x would be 0. Plugging in that for that's your x, that's your y. In this equation, we'd have negative 1 equals 0 for x minus 1. That also works. So it verifies it whenever you check it back in. All right, so that's a review of the graphing method. Now, when you move on into the homework, when you get to number 10, we're using or maybe even before that, maybe it was, number 7. When you get to number 7, it asks you, no, that's still graphing. Where does it start asking you to do a different method? Oh, it was 10. Sorry, my bad. I thought it was 10, and then I looked at the directions wrong. But on number 10 is where you'll move out of the graphing method into the substitution method. So the other two methods for solving a system would be substitution and then the addition or elimination method. Those are algebraic methods to find the answer. All right, so starting at number 10, we have two equations again. And again, if you like graphing, graph them, look for where they cross. But this is a new method that you can use for these two equations. Substitution. So substitution says you solve one of your equations for a variable and then you substitute in that quantity in the other equation. So in this particular one, they've kind of started it out where they've already solved the equation for y, and so is this one. So that first step is done. Again, the first step in substitution is solve one of the equations for one of the variables, whichever one you think looks like the easiest route to go. So we've got that going on here. I'm going to say, just for no reason, it could be either one, but I'm going to take equation 2 and say it's solved for y. Then you take what it says y equals and you plug that into the y in the other equation. So substituting it, subbing it into the other equation for that variable. Again, y equals that, so these are equivalent values. You know, saying these two sides are equal, so they can be substituted one for the other. So we take what it says y equals and we sub that in the other equation for that y variable. So now instead of saying y, we'll say negative x plus 7 equals x minus 1. What that does for us is it gives us an equation that is solvable in one variable. You know, as long as you have two variables in there, you can graph it, but you can't really just solve it and say x equals whatever. So this way, I'll be able to solve. So now I just have an equation in terms of x. I want to bring my x's to the same side, so bringing this x over makes it negative x. I already had a negative x, now another negative x will make negative 2x's. Again, when you're combining these, there's an understood 1 in front of that, so that's a negative 1x, a negative 1x, making negative 2x. Then I'll take the constant 7 to the other side, making it a minus 7, minus 1, minus 7, combining that is negative 8. Now we can solve by dividing by what's on the variable. Dividing the negative 2 by negative 2 makes it a positive 1x or just regular x. Our goal, do the same thing to the other side. Negative 8 divided by negative 2 is positive 4. So now I have the x value solved for. Now remember, the solution is a point, an x and a y, so I need to find the total solution. That's part of it, x is 4. But now that I know x is 4, I can plug that back into one of my former equations here and find the y value. Either one should give you the same answer. So either equation, the first one looks good. We've got y equals, now that we know x is 4, 4 minus 1, giving me y equals 3. Notice if I would have plugged 4 in for this x, y would equal negative 4 plus 7, also gives me a positive 3. So same answer, whichever equation you choose. All right, so our solution then, we can say, is the point, x is 4, y is 3. And we'll write that in our answer box as a point form with parentheses 4, comma 3, final solution. You can also verify that does work for each of those equations. All right, let's try that again. In number 11. Okay, so this one is not solved for a variable already, so it takes it up a notch in difficulty. It's not ready to use substitution. You should have two equations. We'll call this equation 1 and this equation 2, just to help you see there are two different equations there. And we're trying to find what works for both equations, what x, y value. Again, you could graph them. If you're feeling good about the graphing method, graph each one of those lines, look for where they cross. That is the essence of the solution, where they intersect, have a common solution. But the substitution method says take one of your 4 variables. You should have 4 variables, an x and a y in equation 1 and an x and a y in equation 2. Find one of those four variables and solve it for that variable. It doesn't matter which one you use, but you want to pick the easiest one, right? So you see how this is a 1x? It'll be easiest to solve for this x by just throwing the 2y across the line. So I could write this equation as x equals, throw the 2y across, and it'll make it a minus 2y. Now the 6 was already on the right side. This 2y becomes negative 2y, either in front or in back. Don't let that bother you. So then I substitute what it says x equals, because these are equivalent values. X is the same as the quantity 6 minus 2y, so they're interchangeable. So in the previous equation, I plug that in for that x. I substitute it in for this x. Then the equation becomes 5 times 6 minus 2y plus 4y equals 24. And then we'll do our algebra thing there, distribute and solve this equation for y. We've got variables on the same side here, this negative 10y and 4y, they're both on the left side, so we can combine those with our addition rules. A negative 10y and a 4y is negative 6y. The 30 is still over there, equals 24. And you could have put the 30 in front or back, that does not matter, So then we solve for y. We're trying to get this negative 6y alone, so this 30 constant needs to go to the other side. You want variables on one side, numbers on the other side. So consolidate your variables, consolidate your constants. So this 30 moves over and becomes a minus 30. So on the left side, that leaves you a negative 6y equals 24 minus 30, which is negative 6. Last step to solve is divide by what's on that variable. Negative 6 divided by negative 6 makes a positive 1y. Do the same thing to this side, and you'll have y equals positive 1. So that's a good part of our solution. Y equals positive 1. So I know what y is. I still need to know x, so I'll have a point, an xy point. I shouldn't have erased that. I think I can rewrite that quickly. Okay, this is a good place to plug in that y equals 1. Now you could plug it into the original two equations, plug in y is 1 there, or y is 1 there, and then solve for x. But this equation is really the same as that equation 2. I just rearranged it, but it's equivalent. So it's already solved in terms of x. That will be the easiest place, and that's what we always try to do, the easiest path to get to that answer. So if I plug in y is 1 here, it will tell me x is 6 minus 2 times 1, or 6 minus 2, 4. Now I've got my x value. X is 4, y is 1. That should be the point that solved both of those equations. Check it out. Make sure that that's so. Is 5 times, x is 4, 5 times 4 plus 4 times 1, 24. Yes, and it is 4 for x, 4 plus 2 times 1, 4 plus 2 is 6. See how it works for both of those. Now, sometimes there's not a solution. Now, on your number 10 and 11, there will be solutions that should solve out just like this. But sometimes there is no solution. That's why you're seeing that as an option on some of these. Let's see if 12 is one that's special. 12. No, 12 should give you a solution. 13 should. Looks like those work out. Looks like number 16 is going to be a special case in 17. So what I wanted to tell you is, if you don't get a nice flowy solution like these examples, it could be that the lines are parallel. If you solve this system, if you ever get a false statement whenever you're trying to do the algebra steps and you know you've been following the right drill there, if you ever get just a false statement like 0 equals 2, that's because the x's and the y's were the same ratio, and it was a parallel set of lines. If two lines are running parallel to one another when graphed, there won't be an intersection spot, so there'll be no solution. What it looks like when you're doing the algebra is just a false statement. Anytime you run across your variables have canceled out, you've got a false statement left, that's because there were parallel lines and there's no solution. Okay, and that's called an inconsistent system. Now, if everything cancels out and you get like 0 equals 0, that's a dependent system. That's because the lines were just the same line, a line on top of a line. So if you get a true statement, no variables, but you're left with like 7 equals 7 or 0 equals 0. They were the same line or a dependent system.